Alright guys, in our last lesson before we take the test, we're going to talk about some special triangles here. So first off, we're looking at isosceles and equilateral triangles. Let's talk about this triangle in front of us. It has two congruent legs, so that should tell you that that is an isosceles triangle. I think we know that. We've classified it earlier in the chapter, but these pieces all have special names. So first off, the angle that's between the two congruent sides is called the vertex angle. Those two congruent sides are called legs. So the two congruent sides are called legs. The angle in between is called the vertex angle. The two angles across from the legs are called the base angles. And that's because this leg is called the base. So make sure you've made note of all of those pieces so you can refer back to those specific names when we're talking about the triangle. So the base angles theorem, that means we're talking about those base angles, says that if two sides of a triangle are congruent, then the angles opposite them are congruent. So if we're looking opposite, if we know that AB and AC are congruent, then we know that the angles opposite them will be congruent to each other. So if AB is congruent to AC, then angle B is congruent to angle C. Guess what? The converse is also true. So if two angles of a triangle are congruent, then the sides opposite them are congruent. So if we know that angle B is congruent to angle C, then AB is congruent to side AC. Okay, so for example 1, there's those two tick marks showing an isosceles triangle, so then we know by our base angles theorem that our opposite angles are congruent. So then we know that the measure of angle M has to also be 70 degrees. In example 2, we see just the opposite. We see our two base angles being congruent, so we look across, and we know then the length of NP also has to be 18. So example 3 is stepping up our challenge level a little bit, but I see those angle markings again. So I'm looking across from the angle markings. Notice this 20 over here, nothing's happening to it, but I'm pointing to those two sides across from the angles. Those two are equal in length to each other. They're congruent. So I set them equal to each other, and then we solve. So I'm going to add 8 to both sides. So I get 36 equals 9x. I divide by 9 on both sides, and I get x equals 4. And all it's asking for in this case is what x is. So we're done after we find that x is 4. Okay, corollaries to the base angles theorem says that if a triangle is equilateral, then we know that it is also going to be equiangular because those opposite sides and opposite angles all match up. So if a triangle is equilateral, then it's equiangular. The converse to that tells us if it's equiangular, then it's also equilateral. So how does that help us here? Well, if we look at example 4, I see the 60 degrees and the 60 degrees, but there's nothing over here on side UV. But I know that if three angles add up to 180, 60 plus 60 is 120. 180 minus 120 tells me that that third angle is also 60 degrees, which means then that that side is the same as well. So it's an equilateral triangle. So then I can pair up 2x minus 3 with 7 and solve for x because those two sides are equal to each other. So I'll add 3 to both sides. So 2x is 10, divide by 2, and x is 5. All right, those notes were pretty quick today. If you have questions, come in and see me. I will see you in class.